Hi everyone. This is our look at a style of question that asks us to build a redox table when we're given a table of reactions. We're going to be given something that looks like this, with different chemicals going down the side and across the top, and then where we match them up, if there was a spontaneous reaction, we put a plus. And when there is no observable reaction, a minus. This table is going to be provided to us by the question, and we're going to use it to build a redox table. We're going to build a table of reduction half reactions where the strongest oxidizing agent is in the top left and they get weaker and weaker, so our weakest oxidizing agent is in the bottom left. We're going to follow a few steps to do that. First, we're going to decide on the oxidizing agents and the reducing agents. Which part of the table has the oxidizing agents and which part has the reducing agents? Then we're going to focus on just the oxidizing agents and count the pluses for them. And then the more reactions, the more pluses that we count, the stronger the oxidizing agent. This means that the oxidizing agent with the most pluses, with the most reactions, is the strongest. And the one with the second most pluses is the second strongest, etc. That's going to allow us to put the oxidizing agents in order from strongest to weakest, and then we'll write their corresponding half reactions to build our table. Let's go. Our first step is to decide which side of the table has the oxidizing agents, which side of the table are reducing agents. If we look at beryllium, is it an oxidizing agent? Oxidizing agents get reduced. That's a gain of electrons. If beryllium solid gained electrons, it would become a negative ion. And that's not happening. So by thinking about that, I'm able to tell that the chemicals here on the vertical column are the reducing agents. And then by a process of elimination, that automatically means across the top are the oxidizing agents, but I could specifically think about it. Could beryllium ions gain electrons to turn into beryllium solid? Yes. Cadmium ions, radium ions, they could be reduced. They could gain electrons to turn into their corresponding metal. So I looked really closely at what I had in the table, and this example has the oxidizing agents across the top. We can't automatically assume that the oxidizing agents are across the top. We need to think about it. Decide on the oxidizing agents and reducing agents. Focus on the oxidizing agents and count the pluses. Because my oxidizing agents are across the top, I'm counting pluses going down. The beryllium ion, as I just go down, it has one plus in it. It participated in one spontaneous reaction. The cadmium ions here, there's 3 pluses. The radium ions, none. And the vanadium over here, 2 pluses, 2. The oxidizing agent with the most reactions is the strongest oxidizing agent. It's going to go at the top. The chemical here that had the most reactions, 3 reactions was the most. So the most reactions is the strongest oxidizing agent. So that means that my cadmium 2 plus ions were the strongest oxidizing agent. The second strongest one is the one with the second most pluses. That was this one. 3 and then 2. Second most was vanadium. The second strongest oxidizing agent are the vanadium ions. The next one, 3, then 2, then 1. The third one are the beryllium ions. And the weakest oxidizing agent, the one with the fewest spontaneous reactions, is one that had 0 reactions. It's the radium ions. We started by analyzing the table to decide which part of the table were the oxidizing agents, which part were the reducing agents. We focused on the oxidizing agents. Here I was counting going down. I counted the reactions, 1, 3, 0, 2, and that allowed me to put the oxidizing agents in order. Here they are, from strongest to weakest. And now I'm going to write half reactions for those 4 cations. Cadmium is going to gain 2 electrons to become cadmium solid. Vanadium also going to gain 2 electrons. I was able to take this table of reactions and analyze it through a couple of steps and turn it into a table of reduction half reactions, or redox table, where I set it up so that the strongest oxidizing agent is in the top left, the weakest oxidizing agent is in the bottom, and they're in order from strongest to weakest. By doing that, I also end up with my reducing agents in order as well. The strongest reducing agent here would be the solid radium, and the weakest reducing agent would be at the top up there, the solid cadmium. This is a style of question where we're going to build a redox table. The presentation is really unique. We're not going to misinterpret this kind of question for anything else. There's a few steps to follow as we go. Make sure that we're counting in the right way, but it's quite doable. And I hope that helps.